Just checking everybody can hear me. Okay, fine. Hello everybody and welcome to 11 Plus Tutoring. So I work on behalf of AL Tutoring and Oxbridge Tutoring. And what we're going to do is this is fourth, I think, live session where we'll be delivering some of the tricky questions 11 plus. For today's session, I've got some NVR questions to go through in the beginning, and then we're going to go through some English questions and some math questions. So I'm going to share my screen. Give me one moment. Sorry guys, the sharing screen function is moving a bit slow today. Let's see if that works. All right. Right. If someone in the comments just tell me if you can see the screen. Hopefully that is visible now. Okay. I'm going to see if people can see my screen. So the first exercise we have for today, guys, is the odd one out. Now, I don't remember if you remember the last episode where we covered the never say stop to acute panda rule. So that anagram consisted of number, shape, size, total, angle, and pattern. And those are the things that we're looking out for when we're looking at the properties of shapes, when we're looking at non-verbal reasoning. So the question's not on there, but the question for this exam came up as which ones are the odd ones out. And the first thing that I'm looking at when I'm looking at this question is kind of looking at the similarities. So with all of them, I have right angle triangles. Okay. Now they all right angle triangles and they all have a line on them. The next thing I'm going to think about is another anagram, which is called MOP. So that stands for movement, orientation, position, and symmetry. Okay, so the positioning of the line is the next thing I'm going to think about. So the positioning of the line for most of them is that the line is on the top corner. However, for D, it seems to be in the bottom corner. Since D is the only one with the lines on the bottom corner, that must be the odd one out. Hopefully that makes sense. That one was very easy, so let's go to a bit more harder one. I'm going to skip the next one and go straight to this one. So for this one, I have hexagons and I have two lines. Pretty much seems to be the same thing between all of them, but the number of hexagons seems to change. Now remember T in never say stop to acute panda is standing for total. So I'm going to think about that one now. So for the first one, I've got two. What shape is that? So that's S in never say stop to acute panda. So 1, 2, 3, 4, 5, 6, 7, hexagon, excellent. So I've got hexagon. I've got two hexagons here, and I've got two lines. Now I'm starting to think that the number of lines corresponds to the number of hexagons, but let's see if that works for B as well. So I've got 3 lines here and I have 3 hexagons. Okay, that works fine. 3 lines here and 3 hexagons. Okay, seems to be a pattern going on. Oh, I have 2 lines here and 3 hexagons. That doesn't seem to follow the same pattern, but I can't rule that one out. I can't rule that one out just quite yet because I need to look at E. So I've got 1, 2, 3, 4. I've got 4 hexagons and I've got 4 lines. So D is in fact the odd one out, mostly because lines is corresponding with the number of shapes. But can you see how I looked at each one very carefully before I made a conclusion? So that's the thing with odd one out. You really want to analyze each shape that you have before you move and make a conclusion as to what the pattern is before you start to rule them out. Hopefully that makes sense. So the next one, I've got identical shapes on either side. I've got squares and I've got two shapes. Fine. The second one, I've got a diamond, and I seem to have a square on the top and a square at the bottom. Seems to be a white and black theme going on. Yeah, it seems definitely a white and black theme going on. Square, square, always a square at the bottom. Well, what's different at the bottom, guys? What do you think? Can anyone in the comments tell me what they think the pattern for this one is? I'll give you guys 5 seconds or so, 10 seconds actually, to comment what you think the pattern is. Right, so I'm going to get a pen for this one, and I'm going to show you something. I'm going to look at just the top half. Oh God. Hang on. Right, I'm going to look at just the top half of the shape. I have a square here, fine. I have a square here. Now all the other all positioned the same. Yeah, they're pretty much the same. This one isn't quite positioned the same. It looks like a diamond sort of rather than a square. I'm not going to take that one out, but I'm going to take this one. I'm going to take this one. Fine. Bottom. I've got a diamond here. I say diamond, it's just really a square that's just sort of rotated, hasn't it? But the next one's also a diamond. This one is a square. It's not been rotated, so I'm going to leave that one out. Diamond, diamond. With C, what seems to be a problem? Well, the diamond is at the top, sort of the shape that's rotated, and square is at the bottom. And what we've noticed in all the other figures, right, the square seems to be in the top half, and the diamond shape is in the bottom half. So that's the difference between them. Now that one's a bit tricky. That one would have taken a bit longer to figure out. But again, what I did is rather than looking at the shape as a whole, I broke it down. Yeah, it's really just about analyzing the shape. Amazing. So let us move on. So for the next one, I've got find the highest common factor of 60 and 114 and find the lowest common multiple of 120 and 150. Can anyone in the comments type in for me what they think highest common factor means? So I'm going to give you guys 10 seconds or so to see if anyone can tell me in the comments what they think highest common factor means. So I'm going to spoil it for you. So the highest common factor and lowest common factor is some lowest common multiple, beg your pardon, is something that you need to know for the 11 plus exams. Now, in the 11 plus exam, I've never seen them quite explicitly say what is the highest common factor between these two numbers or what's the lowest common factor. No, that question, not that I've seen, comes up. Yeah, not from the top of my memory, anything that's come up. Now, what does come up is that the topic, HCF and LCM, I'm not sure, is integrated within the question. So you often get questions like, I think the most common one is like the flashlight one. So I've got 3 different flashlights. One is at 3 seconds, one at 5 seconds. When is, what's the next time they'll flash at the same time? So 2 different quantities, different times, and when is it going to be again at the same time? And that's where HCF and LCM is really important. Now, for today's session, I do have an example of a question that's come up in the exam paper, but it's really important that you understand first the solid sort of basis of how to find the HCF. And this topic I do teach in an hour, so I beg your pardon if I'm trying to rush it in the next couple of minutes that we have, but I just want to give you a brief overview of how to find out, right? So, highest common factor is also known as the greatest common divisor. right? But in the maths terms and the curriculum and what I think schools, you might have heard it in school as just the highest common factor. It's the largest number that divides two or more numbers without leaving a remainder. Okay, whereas the lowest common multiple is a bit different. It's the smallest positive number. So again, let me just reiterate: it's not nothing to do with negative, nothing to do with decimal numbers. No, positive number that is a multiple of two or more numbers. So highest common factor is the largest number that divides into two or more numbers without leaving a remainder, and the lowest common multiple is the smallest positive number that is a multiple of two or more numbers. Now, hopefully that makes sense. Now, how do we go about working that out? So, I've got 60 and 114. I'm gonna, oh, sorry guys, this thing is very fidgety. So 60 and 114. First step, you have to find the prime factors and that makes 60 and 114. Now, I don't know if I'm just an absolute nerd, but I love working this out. I'll show you why. There's a really cool trick to it. So, two numbers that make 60, guys. I'm just going to tell you the answer. So 2 and 30, right? Is 2 a prime factor? Yes. Why? Because it's only divisible by 1 in itself. So I'm going to circle 2. Now, it is really important. It's really hard to, being a bit hypocritical here, but it's really important to be quite tidy when you're doing factor trees, right? So 30, you've got 2 and 15. Circle 2. 15. Two numbers make 15. I'm not going to circle 15 because it's not a prime factor, right? The 15 appears in other multiplications. So 3 and 5 make 15. Are those prime numbers? Yes, they are. So I'm going to circle it. So the prime numbers that make 60 is 2 times by 2. Can we just appreciate how well I'm writing on this? Times by 5. Amazing. So 2 times 2 is 4, times by 3 is 12. 12 times 5 is, how cool is that? 60. So as you can see, it's just about working with prime numbers only. That's time to make 60. And then 114. Two numbers that make 114. I've got 2 and 57. I might have to run and get a charger very quickly. See if I can pull one from here. Give me one moment. Right. Sorry for the short advertisement, guys, but I thought it might be better to put a charger in rather than having to stop halfway. So, okay. Hopefully, as I was doing that, everyone had a chance to think about the prime factors that make 114. So yeah, so you've got 2 and 57. Now, 2 is a prime number, isn't it? We've already clarified that. And 57 is also, no, it's not a prime number, is it? Because it's divided by 3. Now, how did I work that out without having to do the long method? Well, they might have taught you this in school, but a really cool trick is any two numbers that add up to make a multiple of 3 is divisible by 3. So 5 plus 7 is 12. Is 12 in the 3 times tables? Yes. So therefore, it's a multiple of 3. So 57 breaks down to 3 and 19. Okay, so 3 and 19 are multiples. Now, you might be thinking, why on earth did she do that? Now, the next step for doing this is is drawing a Venn diagram. I love Venn diagrams. They're my favorite type of diagrams. After pictograms, those are really funny. So I'm going to put 60 on one side, and I'm going to put 114 on one side. Now, in the middle, right, in the center, goes what's common between 60 and 114. Okay, which means which which factors come up in both 60 and 114. Oh, sorry, beg your pardon, I forgot to write it down, didn't I? Silly Sam. Right, 2 times 3 times by 19. Amazing. Well, I've got 2 that comes up in both of them, and I have 3 that comes in both of them. I'm going to cross it out. 2, 2. I'm going to write it into my Venn diagram. And 3, 3. I'm not going to cross out 2 again because it's only one lots of 2 I have on the inside. Careful not to make that mistake, guys. So 2 and 3. Amazing. What's left then? 2 and 5, isn't it? And just 19. Now, the highest common factor, remember we talked about it before, is the largest number that divides 2 or more numbers without leaving a remainder, right? And to work that out, you just have to times everything inside the center. Everything that's common between 60 and 114. So that would be 2 times 3, which is 6. Nice and easy. That is how you work the highest common factor. Like I said, guys, don't worry if you haven't figured out in the first session. It does take quite a long time to figure this one out. So the next one, find the lowest common multiple of 120 and 150. Same exact process, nothing changes. I'm still going to draw the factor trees. Can we all appreciate how well I am writing using just the keypad? So we've got 12 and 10. You can do 2 and 60, but actually let's do 2 and 60. I feel like that would save me some time. Or will it? Probably not, no. Probably should have stuck to 12 and 10. Right, 2, I'm going to circle though. 60. I'm going to break it down to 5 and 12. Right, and then 12 goes 3 and 4. And then 4 goes 2, 2. Amazing. Now I'm going to write down everything that makes up 120. So 2 times by 5 times by 3 times by 2 times by 2. Amazing. And then 150, I'm going to break it down to 75 and 2 because I feel like that's the one that's going to be less time consuming. Okay. And then 75 goes 3 and 25. 25 goes 5 and 5. Amazing. And let's just circle everything. Remember, please circle, guys, when you're doing this. Please circle the prime factors. So you don't want to get confused with the numbers that aren't prime factors, right? And then I'm going to write on the side. So the numbers that make 150 are 2, not 2, beg your pardon, lost myself, 75, 3, yeah, no, it is 2. See what happens when you don't circle? You get confused. 3, 5, 5, 2. Same thing, guys, you do the Venn diagram again. Let's do 120 on this side. Hopefully on your piece of paper you guys have done it much more neater than I have, but you have to give me the benefit of the doubt because I am doing it on the screen. So the numbers that are common, well, I have 2 that's common. Fine. Anything else that's common? Yep, I have 3 that's common. By 3. Oh, sorry guys, I forgot to put this on my Venn diagram. 2, 3. Anything else that's common? 5. A lot more common on this one, isn't it? 5. Okay. And then on the side we've got 2. And then all that's left is 2 on this side. And all that's left on this side is 5. Hopefully you guys would have done the same thing as me. Now, lowest common multiple. I always find this quite funny because the lowest common multiple is actually a higher number than the highest common factor. The lowest common multiple is everything in the Venn diagram times together. So what that means is 2 times 2 times 2 times 3 times 5 times 5. Everything in the Venn diagram times together, which is 2 times 2 is 4, times by 2 is 8, times by 3 is 24, 24 times by 5 is 120, and then 120 times by 5 is 600. Don't be like me. Do not do it in your head. I'm setting a very bad example. Do not do it in your head. I've had years of practice. I can do it. I shouldn't do it in my head. But just so it's less time consuming doing it in my head. But please, 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 don't follow my example. Write your workings out. Yeah. So there you have it. Why I say that's funny is because it's quite ironic. Because the lowest common multiple is 600. And then I think for the previous question, what do we get? We got 6, didn't we, for the highest common factor? You'd always think that the highest common factor is a bigger number, but no. That's quite ironic, isn't it? So remember I said to you guys that when you're doing these types of questions, right, and the purpose of this teaching is before the 11 plus exam, right? They never give you a question like this. Not that I've seen it anyway. It's always a question like this. Right, so let me read it out to you. A red light flashes every 6 seconds. A yellow light flashes every 4 seconds. They both flash at the same time. After how many seconds will they next both flash at the same time? That next one is very important. The next one is very, very important. So how many times will they next both flash at the same time? Right, I've seen people look at this question and think, oh my goodness, I have no idea. I'm about to close the paper and run away. Yeah, because it's just all very confusing. But the secret to this one is you need to know the lowest common multiple. Yeah, and that's the way you work this one out. It's just about knowing the lowest common multiple. All you're doing is working out the lowest common multiple between 6 and 4. That's it. Yeah, I'm going to give you guys a chance to do this question in your books or papers, whatever you're doing on, and then I'm going to check back in approximately 30 seconds. So I give you some time for you to do that, guys. I'm going to start sort of drawing it. 6 and 4. Okay, I'm done. Right, so the prime factor tree. The first thing you do, guys, is the factor trees. I always think, why do they call it factor trees? But then I realized that if you imagine it like branches, like these are all stems and the 6 is supposed to be like the top of the tree. Right, so 6. So the 2 prime numbers that make 6, 3 and 2. Are 3 and 2 prime factors? Yes, yes, yes. And I'm going to circle them because we are organized people, aren't we, guys? Yeah. 4. 2 prime factors that make 4. 2 and 2. Nice work. Are they both prime factors? Yes, they are. I'm going to circle them. And then my next step is going to be to draw a Venn diagram, our favorite type of diagrams after pictograms. Hopefully we know what pictograms are at this stage. So then I've got, right, anything that's common, 2 and 2. So that goes in the middle. What's left over? So I've got 3 on this side and 2 on this side. Lowest common multiple, hopefully someone remembers, you times everything in the Venn diagram together. So 3 times 2 is 6. 6 times 2 is 12. Easy peasy lemon squeezy, right? That's all you got to do. Can you see how such a difficult, intricate question really just requires basic knowledge, right? So that's why it's really important to learn in LCM and HM, because I promise HCF, because this question comes up all the time. It's all the time. I'm not going to show you guys this question because hopefully it'll be on the Oxbridge website so you guys can have a go at it yourself. But this is another kind of question that comes up. Teddy the dog barks every 9 seconds, but the dog barks every 12 seconds. They both bark at the same time. How many seconds will next bark at the same time? Really easy peasy, guys. All you're going to do is work out the LCM, which we should all be geniuses at now. So let's skip this part. I'm going to go through both. So write out the first abstract noun in the following sentence. Can anyone in the comments tell me what an abstract noun is? Anyone tell me what an abstract noun is? I'm going to wait to see if anybody comments. Let me see if I can see the comments from here. I just want to see if anybody's commenting. Comments. Anybody know what abstract noun? Thank you very much, Esther. So a noun that is not a physical object. Absolutely, yeah. So a noun that is not a physical object. So let's go back to this. So in the twilight of his career, the that one is quite a mouthful even for me. Paleontologist. So a paleontologist, guys, it's a person, right, who studies a type of science. He studies so fossil animals and plants. So it's normally an expert in that, all things fossil animals and plants, which I know nothing about. I know about plants, just not fossils. Reminisce about his assiduous work ethic over the decades. Right, loads of words, isn't it? So what does assiduous mean? So assiduous means showing great work and so showing like great care and perseverance towards something. So just being quite careful. Yeah. So if our commentator kindly said to us an abstract noun is a noun that denotes sort of an idea, an object, a quality or a state, right? What word in there is an abstract noun? Can anyone in the comments, I'm going to have a look again, tell me what the noun is, abstract noun is in that sentence? I'm going to look to the comments. Anyone tell me what an abstract noun is? What is the abstract noun in that sentence? Give it a guess, even if you're wrong. Do not worry, I will correct you. Right, I'm going to spell it. So the abstract noun in this one is assiduous. Being diligent is the sort of it's like a feeling, right? It's an idea, and that's what the abstract noun would be in this case scenario, right? Like I said, this requires a lot more. It's more of an hour's topic there, but that's what, just a brief overview of an abstract noun. It's an idea or a feeling, right? It's nothing like an object. Now let's finish off with this one. So, true or false, the sentence below use punctuation correctly. Now, these ones are examples of something called parenthesis. Now, a parenthesis often comes in the form of brackets, or it comes in the form of dashes, right? And now a parenthesis is a word or phrase that is inserted into a sentence, and what it does is it provides extra clarifying information, right? So it provides information that, not necessarily that we don't need it, but if I was to read the sentence disregarding the bracket, the sentence would still make sense. And I'll show you what I mean. The muscular athlete, I'm going to ignore what's inside the brackets, guys, just to prove a point. The muscular athlete won the race for his second year of running despite suffering from a knee injury. Does that make sense? Yeah. I asked myself a question and answered it, right? The second one, Olympic swimmers who train every day, as well as 2 silver ones. Does that make sense? What I've done there, if you notice, I've completely disregarded what's between the dashes. Does that make sense? No. Okay. So that sentence is definitely not punctuated correctly. The last one. My pet rabbit has a strange blemish on her left ear. Does that make sense? Yeah, it does. disregard what comes in between the commas, right? And I should have mentioned it before, but parentheses can actually come in the form of commas, right? Now, what the extra information is Ben Hardy. Oh, Ben Hardy. This one is finally won a gold medal this year, right? And then the last one is in between the commas, the same one I had 3 years ago. That's what the extra clarifying information is. But like I said, it only makes sense, right? If I was to disregard what's in between the parentheses, right? If it's punctuated by brackets, commas, dashes, whatever, the sentence would still make sense. And that's how you can test if the punctuation is correct. Now, this question, parentheses, I know it says punctuation there, but the actual topic comes on the parentheses, is a very common topic, which is why it's really important to know how to use your brackets and how to use your dashes. And without further ado, I think we'll go to start there. So, right. I'm going to see if anyone has any questions today. Does anyone have any questions before I close things up? About 30 seconds or so. No? Okay. Amazing. So that brings us to the end of today's session. Okay, and I hope you found these strategies really helpful. If you'd like to take the preparation further, Oxbridge is, if you click on that QR code, they're offering a free 11 plus assessment for students. So if I were you, what I would do is scan that QR code, right, and that can take you to the Oxford website where you can complete an assessment. Okay. Now I've tried this assessment myself. Okay. Not because I have nothing better to do, because I wanted to see how long it takes me, so I can give you an accurate time. It takes around 15 minutes, guys. 15 minutes of your day, and you can answer all things questions. And what it does, which is really, really cool after, for parents, more so than for students, is it allows you to book a consultation where you can get a free trial, have one-to-one tutoring, and it might be with me if you're lucky, or might be someone else, and that one-to-one tutoring is very helpful. So after each session, what will happen is that parents receive a detailed summary. Students get a quiz tailored to the topic they've covered. How cool is it to get a quiz tailored in just for you? Yeah, not a generic quiz, it's just tailored just for you. And we'll create a personalized learning plan to target key areas, and this is all leveraged by AI. So really cool stuff, guys. It's something that it's something that's very unique, and it will, as you're preparing for 11 plus, it's massive help getting feedback that's just tailored to your strengths and weaknesses. Okay, so if you are interested, please scan that QR code, book your consultation, and hopefully I should see you on the other side if I get to tutor you. And another thing that you guys can also do is submit your questions to go through next week. So each week on Mondays, sorry for the late start today, guys, but each week on Mondays, normally, promptly at 6, I deliver live sessions on questions that I've seen that are tricky in exam papers. But I would love if you guys can send your exam questions to me, then I can go through it. How cool would it be to see your question featured on YouTube? But without further ado, I just wanted to share a couple of bullet points of why Oxbridge X. The reason why Oxbridge X differentiates between different tutoring companies, and this is also for the parents. So if students have zoned out at this time, it's absolutely fine. But for parents, we have experienced tutors from Russell Group universities, and that includes Oxford, Cambridge, and other universities, right? Summaries for parents. I think the most important thing when you're doing 11 plus, especially leading up to October, November when your exams are, is having feedback that is tailored to the student. Right? What can the student work on? And having that after each lesson is critical. We can only progress, right, if we know what to work on between now and next session. A quiz after each lesson. Sometimes it's really easy. I've seen it happen a lot. After the session, bye, see you later, and then the kid just forgets what happened. Right? Quizzes help consolidate answers, especially quiz specified to what the session is about. Right? And what is really cool about this is it's an AI-driven personalized lesson plan, right? So it generates by AI on everything that's happened in the lesson, which is, if you ask me, really, really useful. Okay, and that's why Oxbridge X differentiates between different tutoring companies. But that is all for me today. I know I've talked a lot. So if there are no questions, I don't think there are. Someone's just said a noun which you can't touch. Yes, a noun which you can't touch. Amazing. Thank you, Lena. So if there are no questions today, I will be on my way. And please make sure, if you really like this video, to like, comment, and subscribe. And hit the notification bell so every day at 6, if I'm prompt, hopefully next week will be prompt, you don't miss our next session. Yeah. Thank you so much for joining, guys, and I will see you guys next time. All right, bye-bye.